Hi guys. So we're welcome back again to my another video. For today's video, we'll do the chapter 9 summary. So let's go. Chapter 9 summary is transport layer. On chapter 9, the sections and objectives are the transport layer protocols, TCP and UDP. There are only two section objectives for the chapter 9. Transport layer protocol. The role of the transport layer. Responsible for establishing a temporary communication session between two applications and delivering data between them. Link between the application layer and the lower layers that are responsible for network transmission. Transport layer responsibilities: tracking the conversation, segmentation, identifying application. Tracks each individual conversation flowing between a source and a destination application. Divides the data into segments that are easier to manage and transport. Either used for assembly is used for tracking. Identify the application ensures that even with the multiple application running on a device, all application receives the correct data via port numbers. Conversation multiplexing. Segmenting the data into smaller chunks enables many different communications to be multiplexed on the same network. Transport layer reliability, TCP or IP, provides through two transport layer protocols. Transmission control protocol, considered reliable, which ensures that all of the data arrives at the destination. Additional fields needed in header, which increases size and delay. Use datagram protocol or UDP. TCP or IP. TCP transport is similar to sending truck packages. If a shipping order is broken up into several packages, a customer can check online to see the order of the delivery. TCP 3 responsibilities: number and tracking data segment, acknowledging received data, retransmitting any acknowledged data after a certain period of time. UDP. Use UDP for less overhead and to reduce possible delays. Best effort delivery, no acknowledgement, similar to a non-registered letter. The right layer protocol for the application. TCP uses databases, web browser, and email clients require that all data that is sent arrives at the destination in its original condition. UDP: if one or two segments of a live video stream fail to arrive, if disruption in the stream may not be noticeable to the user. TCP features: establishing a session, reliable delivery, same order delivery, and flow control. Establishing a session, connection-oriented protocol ensures that application is ready to receive the data, negotiate the amount of traffic that can be forwarded at a given time, ensuring that each segment that the source sends arrives at the destination. Same order delivery, numbering and sequencing the segments guarantees reassembly into proper order. Flow control regulate the amount of data the source transmits. TCP the source and destination port used to identify application. Sequence number, acknowledgement number, header length, control bits, window size, and checksum. UDP features. Data is reconstructed in the order that is received. Any segments lost are not resent. No session establishment does not inform the sender about resource availability. UDP is a stateless protocol, no tracking reliability handled by application. Multiple separate communication. Users expect to simultaneously receive and send email via websites and make VoIP phone call. TCP and UDP manage multiple conversations by using unique identifiers called port numbers. Port numbers: source port, destination port. Socket pairs: source and the destination port placed in segment encapsulated in IP packet, IP and port number. Sockets enable multiple processes to be distinguished. Source port acts as a return address. Port number groups. Well-known ports 0 to 1023, 1024 to 429, 49151 registered ports. Dynamic or private ports is 49, 49 152 to 65, 553. Port number groups. The netstat command. The network utility that can be used to verify connections. By default, will attempt to resolve IP address to the domain names and port numbers to well-known applications. TCP and UDP. The TCP server process. That's three source the three five process of TCP. Request destination ports. Client sending TCP request source ports. Response destination ports and response source ports. TCP connection establishment. Step 1: initiating client A session with server. Step 2: server acknowledges and requests a session with. Step 3: client acknowledgement communication session with server. TCP session termination. To close connection, the finish control flag must be set in segment header. To end each one-way TCP session, a two-way handshake consisting of a fin segment and an acknowledgement segment. TCP three-way handshake analysis. The three-way handshake establishes that the destination device is present on the network, verifies that the destination device has an active service and is accepting requests on the destination port number that our initiating client intends to use information destination that source client intends establish a communication session on the port number. TCP reliability. Ordered delivery. Sequence numbers are assigned in the header of each packet, represent the first data byte of the TCP during session setup. An initial sequence number is set, represent the starting value of the bytes. As data is transmitted during the session, the sequence number is incremented by the number of bytes that have been transmitted. TCP flow control. In the figure, the source is transmitting 1460 bytes of data within each segment, which window size agreed on during three-way handshake. Typically, PCB will not wait for 10,000 bytes before sending an acknowledgement. TCP flow control. Congestion causes the transmission of lost TCP segments. The transmission of the segments can make a congestion worse. To avoid and control congestion, TCP employs the several congestion handling mechanisms, timers, and algorithms. UDP low overhead, UDP not connection oriented. No retransmission sequencing and flow control. Functions not provided by the transport layer implemented elsewhere. UDP data program reassembly. UDP reassembles the data in order receive and forwards the application. Application must identify the proper sequence. UDP server processes and requests. The remote authentication dial-in server service reduce server shown in the figure provides authentication, authorization, and accounting services to manage UDP client processes. Application that use those TCP. TCP frees application from having to manage reliability. Three types of application best suited for UDP. Live video and multimedia, simple request and reply, and handle reliability. And that's all for chapter 9. So I hope you guys understand my explaining, and I hope you had a little bit learning from me. Thank you guys, and good day.